let's try another example. This one you need to solve by your own. I just give you the hint how to solve the equation. A transverse traveling wave on a chord is represented by t 0.22 sine 5.6x plus with 34t. So compare to the general equation. So then you know what is a 0.22, what is a 5.6, what is a 34. Positive here means that the wave traveling to the left, where D and X are in meters and T in second. So for this wave, determine the wavelength. So how to find the wavelength? Wavelength equal to 2 pi. Sorry, the wavelength you can use the equation of K equal to 2 pi divided by lambda. K already given in the information out there. So just substitute all the information. K 5.6 here. So you can find 2 pi is constant, so you can find lambda. Frequency, to the information from here, 34. 34 represent the lambda, so you can find the lambda because, sorry, you can find the omega. Here is 34 is omega. So you can find the omega equal to 2 pi f. So then you can find the frequency. The velocity equal to f lambda. F from part 2, lambda from part 1. So you can find the velocity. Amplitude, this is amplitude, 0.22, is it? Are you with me, class? And the last one is the maximum and minimum speed of particle of the chord. So how to find the maximum and minimum speed? Okay, try by your own. The second, next example is a progressive wave on a string is represented by the equation y 6 sine 200t minus with 10x minus here representing wave is traveling to the right, where x and y are in meters and t in second. Compute the speed of particle of the string at x equal to 20 meter and t equal to 2 seconds. Compute the speed. The question asks for the speed. As you can see here, given x at 20 meter and t at 2 seconds already, this means that you need to use the equation of velocity in the function of x and t, which is v equal to a omega cos sine k minus omega t. So took all the information here, so you can find the speed and substitute the x value and t value in this equation. Okay, good luck. Alright, the last subtopic for today is energy transport. Okay, for a sinusoidal wave of frequency f, the particle move in a simple harmonic motion and each particle has energy, as you can see in the figure. So the energy, when there are velocity here, there are energy. So L here represent the distance travel equal to VT, and A prime, as you can see, the prime here represent the area. Okay, for energy transport by a wave is proportional to the square of the amplitude. So energy in joule equal to half KA square. A is the amplitude because the square of the amplitude here mentioned already. And then we expand the K from the information here, from the equation here, expand the K. So K, derive the K. So K equal to 4 pi square F square times with M. So we got K. So substitute in here, simplify 4 divided by half. So we got 2 pi square M F square A square. Alright. M is the mass of particle. Okay. For a 3D wave traveling in an elastic medium, assuming the entire medium has the uniform density R. So let's have a look. M is equal to rho V. Rho is the density, V is the volume. Equal to rho A prime times L. A prime is represent the area. And if let's say there are no L given, so we substitute L by the L equal to Vt, represent the length, which is time with V time with time. So substitute all the information into the M from the equation of energy. So this is M equal to 2 pi E energy equal to 2 pi squared rho A prime V velocity time with T F squared A squared. A here represent the amplitude. Therefore, the energy transported by a wave is proportional to the square of frequency and square of the amplitude, as you can see in the equation here. Then energy over time is the average power. The power is, unit of the power is watt. So just put the equation of energy divided by the time. As you can see here, the missing information, I focus on the missing information only. So take all the information, all the equation of the energy, and then we divide by the time. But I just focus on this S and T. So I just took the missing information from the equation of energy, S. How come, where is S come from? So actually S is equal to energy divided by the time. Actually in previous equation there are A prime times with T and divide by T. T here is when the energy divided by the time. So I suppose here there are 2 pi square rho V F square A square, but I just focus on this. Again, I mentioned I just focus on this because I want to show how the S replace, how the S get here. So then we just cancel out the T, so only A prime left here. Then we replace the A prime with S. So that's why we got this equation. Next one, intensity. Intensity equal to energy divided by the time. So we already find the power from the energy divided by the time. Then divide again by the area to find the intensity. So we just took this equation, or this equation here. Okay, then I just focus on A. I just took the A. Okay, so then took the equation here. All the energy power here just divide by the A area, A prime. So then the area here, as I mentioned, I show you here earlier, represented by S. So we can cancel out A prime S. So that is why we got this equation for intensity. So from the equation, we know that intensity is also proportional to the square of the amplitude. Therefore, intensity decrease with distance and amplitude of the wave will also decrease with the distance. Alright, that's all for part 1, chapter 2. I will proceed with part 2 from 3.4 to 3.7 by next week. Thank you for listening to me and enjoy the lecture. And if let's say you not understand some of the lecture given by today, you can ask your lecturers. Bye bye. See you again.